Hello and welcome, my fellow math mortals. Today we're going to go over this TI84 calculator program for physics mechanics. You see all the topics it can cover: kinematics, dynamics, work and energy, momentum, rotational, gravitational. Basically a first semester college class in physics mechanics, or an AP class going over mechanics, or anything that goes over physics mechanics. But today we're going to go over dynamics, and the second half, or the second and third part of this, we're going to go over first some friction problems, then some net force problems, and then I think some tension and normal force problems to get this done. So first thing is we're going to go over problem 1 here, the friction. So we're going to go to option 3, and then calculate, and I'll walk you through what's going on. Sorry if this is a little rough here. Calculate the maximum static friction force for a 10 kilogram box on a surface with mu, and this is a mu. It looks like a cross between an M and a U. It's actually a Greek symbol, mu. Mu S, meaning mu sub S, like static friction, the coefficient of static friction. And then so a few things, if you're not familiar. If you are familiar, go ahead and just fast forward. Static friction, so we know it's going to be static under this option. And then it gives you the formula. The force of static friction is mu sub S, the coefficient of static friction, times N. N is the normal force. So I want to talk about that. What does normal force mean? It's a little funky. But if you have a box, let's say, on a surface, okay, and the box is going this way, to the right, the normal force is the force, I'll make it hot pink to match the formula here. This is the normal force, the F sub N, meaning subscript N. The normal force is perpendicular to the direction of travel. So it's the 90-degree angle here. Typically, and not always, but typically it's just the force of gravity. If it's on a flat surface, yeah, it's the gravity force. So force normal is mass times g. G, the acceleration due to gravity. That gets a little weird. Because I know in AP stats, at least, or no, sorry, AP physics in the States, G, they round to 9, but most people use 9.81 or 9.8. So let's, without further ado, the other problem won't take so long. I just want to introduce you to all this. The mu sub S is 0.45. Usually it's some number between 0 and 1. This one's 0.45. And then the normal force is 98.1. That's going to be the, by the way, that's going to be the 10 kilograms times 9.81 meters per second squared, and that comes out to be 98.1 newtons. And newton is a gram, 1 kilogram meter per second squared. So the normal force here, 98.1. That's how we got that. Most of the formulas and the equations are going to be covered for you, by the way, in this program. I just want to introduce this one, and then also the net force problem, just like a short explanation of how I got the numbers. So look, we get 44.145, and that's going to be newtons, because that's the static frictional force, or F sub S. I can't do subscripts with what I'm using, but it would look more like this in your book, like F with a subscript of S there. Okay, on to question number 2 here in the friction. A 5 kilogram box slides across the floor with mu sub K, that's the coefficient of kinetic friction. So mu sub S is static friction, mu with a subscript of K is kinetic friction. The normal force is 49.05 newtons. What is the kinetic friction force? So the cool thing is it's already decided for us it's going to be a kinetic friction question, so we're going to go to option 2. And the mu sub K, and I'm just writing this down. Like, for instance, I'll highlight what you'd want to write down. It just kind of helps you organize your thinking, organize your approach to the problem. Is that we have mu sub K is 0.2, and N, capital N, is usually the normal force. It's 49.05 newtons. So mu sub K, 0.2 for that one. And then the normal force is 49.05. Again, I'm not using units. This particular program doesn't include units because sometimes teachers will switch between grams and kilograms. It messes everything up. So make sure if you're going to be talking about newtons, your kilogram meter per second squared. So here we get F sub K is 9.81, and that's our answer right there, 9.81 newtons. Okay, good. Let's go into net force problems. That's option 4. And then we're going to get it here. So net force problems, the first one is, what is the net force when a 25 Newton force, and a 50 Newton force act in the same direction? So one note here, if the same direction, we're going to assume they're both positive. If one is, say, going to the right and one is going to the left, that would have been positive 25 and negative 15. Just to give you a heads up on that so you're not confused later. So we're going to do two forces here. F1 is 25 for 25 newtons. And you just want to make sure both of these are in the same units, because some teachers are a little, tricky, and they're like, oh, is he paying attention? I'm going to put one in newtons and one in another force. So they're both newtons, so that's cool. We can do that. And so the F net is 40. And notice here, it actually gives you the formula you need. So if you do want to write the work there, you can say, oh, F net is F1 plus F2. And if you're writing everything down, it covers you, so your teacher knows, like, oh, okay, this student knows how to do the problem. Okay, we're going to go net force problem once again. And then 3 forces act on an object, 30 newtons to the right, 15 newtons right, and 10 newtons right. So we're going to assume here right is going to be the positive direction, meaning left would be negative direction. They're all going in the same direction, so they're all going to be positive. So we're going to go to 3 forces here. F1 is 30 for 30 newtons. F2 is 15 for 15 newtons. And F3 is 10 for 10 newtons. And we have 55 newtons. There we go. We're doing well so far. Okay, we're at more than the halfway point. This is good. Let's go to tension here. Calculate the tension. Oops, let me scroll over a little bit so we can see everything. Of a rope pulling a mass with an acceleration of 3 meters per second squared. So this looks like it's a single mass here. And what is the mass? Oh, it's 2.5 kg. So for M, I'm going to put 2.5. And again, this part wouldn't be given to you right here. This part is, I'm going to underline this. We're going to write the given. That's usually a good idea. Again, just to kind of clarify your thinking. And the acceleration is 3 meters per second, so we're going to put 3 there. And it gives us, the formula, so you could, write that on your paper. And then, the tension is 7.5, so 7.5 newtons. There we go, we're on the right track. Okay, we're going to go to tension yet again. And now we have 2 masses. So find the tension rope connecting 2 masses where, I'll scroll it up for you, M1 is 4 kg and M2 is 6 kg. So 2 masses. And then M1 is 4, and then M2 is 6. And the G, now again, sometimes I automatically have this set to G as 9.81, but I know some of you guys are going to be using 9.8 or rounding it to 10, so you can plug in 9.81 or whatever your G value is. That's the acceleration due to gravity. And then, okay, the tension is, and again, we have the formula right there. That's fantastic. Helps us out. 23.544 newtons. There we go. I'll underline that in black. And we're on the right track again. Okay, now for the normal force problems. So we're going to go to option 6 under the dynamics equations. Now, find the normal force exerted on a 12 kilogram box resting on a level surface. So it's on a level surface for the normal force here, so we'll choose option 1. And then, what is the mass? The mass is 12. And then what is the G? It's 9.81. Okay, cool. 117.72 newtons. Very good, very good. And we have it. Okay, now for this second one, it says calculate the normal force on an 8 kilogram object on a 25-degree incline. So look, one thing I want to mention to you here, I'm going to quit the program. Actually, I can't. I have to go back and quit that way. You do want to go to mode because if you're taking, say, trig or calculus right now, your calculator is probably in rating mode. So look here on the third option down. It might be different if you have a different version of the TI84 Plus, but you can toggle between rating and degree. Typically, it's going to be degree, but if it is radian, you know, if you see something like, oh, it's pi over 2, theta is pi over 2, that's typically going to be radians. But make sure you're in degrees, because I did this problem practicing for this, and I had it in the wrong mode. I was getting the wrong answer. So again, we're going to go to dynamics, and we're doing normal force here, option 6, and then we're going to do it on an incline, okay? So, oh, what is the M? Oh, the mass is 8 kg. The G, in our case, we're going to assume the G is 9.81 again. Your G in your class might be more or less accurate, or it might be 10. I'm not trying to dig on the AP physics students in the United States, but, you know, so it goes. And then what is the theta? It's 25. So just remember, if it's in degrees or radians, make sure your mode is correct, so you get the correct answer there. Okay, and we get 71.12 newtons. Fantastic. So just keep in mind, if this helped, you can like it. If you dislike it, give me a thumbs down. I don't care. That's cool. It's part of the game. Comment if there's something that you would like to see or an improvement that could be made. I do take those to heart and do include those in iterations, different iterations of the program. If there's an error that you run into while running your program, let me know, because I've done that for other programs I've made. I was like, oh my gosh, I didn't know there's an error for like some obscure use of it. And then I corrected it and sent it to everyone who had bought it. So you do get, if there's errors, let me know. I'll fix them and give you a free revision, no problem. Okay, and this is available at mcstutoring.com. That's M as in Mary, C as in Charlie, S as in Sam, mcstutoring.com. The link is in the description, along with other calculator programs that are popular right now. The SAT math program is always selling like hotcakes. And then other than that, I think this physics mechanics solver is doing pretty well, along with the chem solve. The chem covers everything in usually a first-year chemistry class. Not everything, but I'd say 80%. But look, if there's stuff you want to see in other programs, let me know. Comments, I do read them. Okay, take care and good luck in your physics endeavors. I'll see you next time.